Good afternoon, ladies and gentlemen, and I hope you all had a pleasant enough spring break. I, of course, am kicking off my spring break by recording this video while I still have the test in front of me and fresh. So, let's get right to it. If you were in Siberian's class, I just wanted to point out to you, this was probably my favorite test in terms of how it was paginated, not in terms of its content. As you can see, we had nice ledger paper. That way, it folded completely flat. And my compliments to the print shop for that capability. Okay, so let's start with number one. Let's see if I can get this to actually look decent. Okay, so for the first one, there we go. Which answer choice describes the following in log form? So you had to recognize you had your base, your exponent, and your term. Well, immediately you could eliminate from consideration C and A because the base is wrong. Now, the base was large, the base becomes small. The exponent was near, the exponent becomes far from the base. So the correct response was B. Okay? And that's it for that one. Number two. You have, let me zoom this out. You have a culture of 3,000 bacteria that quadruples in size every 10 minutes. PFT represents the function, which of the following works. Now, 3,000 bacteria, they all have the same leading coefficient. That doesn't eliminate anything. Well, it says quadruple. To quadruple is to multiply by 4, so B is clearly and obviously wrong. And it quadruples every 10 minutes. So at 1 minute, it has not quadrupled in size. It hasn't quadrupled in size until you get to 10. So we know that A is wrong because it doesn't have anything to do with 10. And this means it quadruples 10 times for every minute, so the correct response was C. Now, for number 3, you are being asked to find the percent of depreciation. How much is this going down? So what you will do is you will take 1565 and you will divide it by 2300. So you're going to take 1565 and you are going to divide it by 2300. And I'm still in scientific notation. Let me get this back to normal. 68. 68% is what you are actually being evaluated on, but it said what is the percent of depreciation, which is to say that you're looking for your rate. So this is actually going to be, your function with respect to time is actually going to be 2300 times 1 minus a rate set to the power of the time. Now, to get to 68, well, we just say, okay, what's 1 minus that previous answer? And you get 31.9, which is about 32%. So it required you to know, hey, you have to subtract 1 from it, and you have to be able to round. Okay. The next one is, what is a reasonable approximation for log 5 of 31? Now, if you knew your log base command on your calculator, that's nice. That was a very easy question. Even if you didn't, you know your change of base formula. Y is equal to the log 5 of 31 is to say the log of 31 over the log of 5. Remember, 5 is your base, and when you do your change of base, your base is down low. Gotta get low. Alright, so what you do to your calculator, you go on ahead and you say, alright, the log of 31 divided by the log of 5, and that gives you 2.13, which is about 2.1. Now, those of you who don't believe me, you want to do the log base, okay, we're going to go to the catalog. They see me scrolling, they hating, patrolling. All right. So let's see, we're going all the way up to log base. Actually, this is going to take us a while. So we say alpha, and alpha isn't there, and alpha L for log. And then we go down to scrolling, log base. Okay, so we say, okay, log 5 of 31, and lo and behold, it's the same thing. Behold, the change of base formula works, and I like the change of base formula better because I was trained on scientific calculators back in the 90s. The 90s were a wonderful time, by the way. Okay, that was easy. On to the next one. Which of the following is the inverse function of the thing shown in the graph? Now, first of all, we know that because this is going up and because it has a asymptote at 0, that this is actually an exponential function. This is actually the function y is equal to 2 to the x. We know it's 2 to the x because x is equal to 1, y is equal to 2. X is equal to 2, y is equal to 4, x is equal to 3, and y is equal to 8. It doubles each time. So that was the original function that they gave us, and this is a base of 2. What cancels base? Log cancels base. So the inverse function is y is equal to the log 2 of x. Now, if you don't believe me, we can always graph these bad boys. And you can actually say, okay, so you have 2 to the x as your original function. And then you have the log 2 to the x, which is the same as the log of x divided by the log of 2. And they should look like mirror images of each other. There's the first one, and there's the second one. As you can see, if we go to the zoom square, it looks more like inverses of one another. And we could actually take our line y equals x and bisect it. And in actuality, we could actually compose the two functions together. And you would still get the function y is equal to x. And so there's our inverse coming up. So lo and behold, they are inverses of each other. So that was fun. Okay, now this one was a little bit more fun. You are being asked to plug in 2 interest problems. Now, there are 2 things we have to recognize when we're doing this, and the easiest way to do it is to use our machine. So we're going to take our calculator, and the first one, either way, you start off with $1,500, and we're looking at where y is equal to, or where x is equal to 3, right? So we've got $1,500 times 1 plus our rate, which in the first case is going to be, so we're going to take our fraction, 0.06 for 6%, divided by, and it's being compounded monthly. Well, how many months are in a year? Well, there are 12 months in a year. And we're going to close it up, and we are going to set it to 12 times x, and that's our first function. Our second function is going to be 1,500 times 1 plus, make the fraction again, 0.054 daily. How many days are in a year? 365. If you want to be really particular, 365 and a quarter, but not really. Especially not in the first 3 years unless you started off in the middle of the leap year cycle. So again, this is going to be out of 365x. And so those are your 2 functions. Now, as we look at our answer choices, it's asking you which one gives more money. So that means we need to know the difference between the 2 of them. So what I'm going to do for my y3, I am actually going to compare my y2 from my y1. So I'm going to take my y variables. I'm going to take the function of y1 evaluated at x minus the function of y2 evaluated at x. Now, if A is more than B, it'll give us a positive result. If B is more than A, it'll give us a negative result. So now we're going to go to our table. And we are going to scroll down to where x is equal to 3. And we're going to scroll over to our y3, and we find that where x is equal to 3, y1 is 31.252 more than y2. And so that's how we got our C. And that was it. Okay, next one. In the equation A is equal to the log B of C, what type of numbers can be used for A? This is basically asking us what type of numbers can be exponents. B is your base and C is your term. Now, basically, can you have a negative exponent? Yes, you can. Remember, whenever you take a negative exponent, you are dividing by the base. So, the exponent can be any real number. And the other choices were mere distractors. So that was fun. Alright, next one. Solve the following inequality graphically, which I found very amusing because they didn't give you any space to actually solve it. And I wouldn't have solved it graphically. I would have solved it algebraically, especially since they didn't give you any space to solve it graphically, and so I just thought they were being kind of funny. So what I'm going to do, just to make my life easier, is I'm going to show you how you can kind of sort of solve it. We'll do it graphically. Jeez. I'll show you both. Alright. So the first thing is we have our y1, which is 4 times the common log of x plus 6. And then we're going to add the constant 3 to that, and then we are comparing it to 5. And so we go to our calculator. Here we have our nice logarithmic function, and there we have our constant line 5. Now we're looking for where the logarithm is less. Okay, now this tells us we have a bound. Okay, we have an asymptote here at negative 6 because you can't take the log of 0. So if we go to our table, we see that where x is negative 6, we have an error. That's the beginning of our asymptote. So right away we can eliminate D, because the asymptotes are going the wrong way. The other thing we can do is we can eliminate B and A because you don't have the bound correct. Now, you're not going to find, you're going to have to actually go back to your graph and calculate the point of intersection. And so, is this the first curve? Sure. Is this the second curve? Sure. Yes? Yes. And so that's where we get the 2.838 from. So remember, x is less than, which is to say below than, this point, right? Now the reason it cuts off is because further left it's undefined. And so that's all there is to it. If you had solved it algebraically, you would have had to remember the restriction on the domain that's imposed by x minus 6. You have to look for the zeros of the logarithm. Okay, the next one, you could have arrived at it, again, either graphically or by solving. I'm going to show you the graphic solution, and then I will show you kind of an easy way to get there algebraically. Okay, let's start. First of all, actually I like the algebraic way easier first. So, can we combine this into a single term? Sure we can. We see that we have subtraction of the logarithms, which means we have division of the terms. So, we're going to start off by combining our logarithms, and we're going to have the log 3 of x divided by 2x minus 1. The reason we're able to do that is because where you subtract the logarithms, you divide the terms, and we set that equal to 0. Now, at this point, we can actually rotate things around and put this in an exponential form, and things will make sense. So, here's our base, here's our exponent, here's our term. So we have x over 2x minus 1 is equal to 3 to the 0. Now, at this point, you have to remember the axiom that any non-zero base to the 0 power is 1. So now, you have, and I'm going to actually slide this over to the blank spot on the right, you have x over 2x minus 1 is equal to 3 to the 0, which is 1. Well, oh, there we go. Well, now you're just dealing with a rational function. And what's the first thing you're going to do when you have a problem with a fraction? You multiply by the denominator. You're going to multiply both sides by 2x minus 1. Well, 2x minus 1 cancels 2x minus 1. X is equal to 2x minus 1. You subtract x from both sides. You have 0 is equal to x minus 1. And then you add 1 to both sides. And this gives you that x is equal to 1. And that's your final solution. Now,